Hi everyone, today I'm going to show you how to solve the questions of linear algebra which were asked in the GATE 2024 in the electrical engineering exam. So the first question is, which one of the following matrices has an inverse? Now, what is an inverse? So matrix A has an inverse which is written like this if its determinant is not 0. So for the inverse of the matrix to exist, it must satisfy the two conditions. The first condition is the matrix must be square. So as you can see that all of these four matrices are square. These are 3 cross 3 matrices. So the number of rows equals to the number of the columns. So these are square. The second condition is the determinant of the matrix must not be 0. So now let's calculate the determinant of all of these four matrices and see whose determinant is not equals to the 0. So that will be our answer. Let's find the determinant. So I hope that you have learned how to find the determinant in your previous classes. In your calculation of the determinant is very simple. First you write the element A11. See, when I hide this first row and the first column, then what remains is 4, 2, 2 and 4. So I write it over here. And after that, the second element, that is 4. So when I hide the second column, so what remains is 0, 0.5, 2 and 4. This. So I write it like this. And always remember that for the first element, it is always positive here. And for the second, we write the minus, and for the third we write the plus. So we write it as like this, plus minus plus. And for the A33 element, just hide the third column. So what remains is 0, 4, 0.5 and 2. So simply we write it as like this. Now 4 into 4 is 16, minus 2 into 2 is 4, then minus 4, 0 into 4. See, we have to multiply them diagonally. So 0 into 4 is 0, minus 0.5 into 2 is 1, plus 0 into 2 is 0 only, minus 0.5 into 4 is 2. So when I solve this, I get the determinant as 0. Similarly, we can find the determinant of the second matrix, and its determinant is also equals to the 0. And this is how you can find the determinant of the C matrix. And here the determinant is not equals to the 0, it is equals to minus 12. So its inverse exists. So it satisfies the both condition that the matrix must be square. This is the answer. And this is the determinant of the matrix D. Here also the determinant is equals to 0. So its inverse also does not exist. So our answer is option C. And the second question from the linear algebra is, we have to find the sum of the eigenvalues of the matrix. So it is the square of the 2 cross 2 matrix. So first of all, we have to find the square. We have to do the standard matrix multiplication. So it's a square. See how to do the matrix multiplication of the 2 cross 2 matrix. By the help of this formula, we can evaluate it. This is the formula to do the multiplication of the 2 cross 2 matrix. See here, A is this element, B is this element, C is this element, and D is this element. Similarly this. So how to do the multiplication? See, A into A, that is A square, plus B into C, A square plus C. Similarly, the first row, this is how you can write the A matrix after doing this multiplication. So 1 into 1 plus 2 into 3. This is A11. Then 1 into 2 plus 2 into 4. A12. Then 3 into 1 plus 4 into 3. Then A22 is equals to 3 into 2 plus 4 into 4. So after solving this, we get the value as 7, 10, 15 and 22. So this is how you can do the multiplication. So now after writing this A, we have to find the sum of the eigenvalues of the matrix A. Now here, what is the meaning of this eigenvalues? So an eigenvalue is a scalar associated with the square matrix and it is represented by the symbol lambda, and the sum of the eigenvalues of a square matrix is equal to the trace of the matrix. Now what is trace? So the trace of a square matrix is the sum of the elements on its main diagonal. So it is simply the addition of the diagonal elements, that is 7 plus 22, it's equals to 29. So this is the sum of the eigenvalues of the matrix A. So it is so simple. So thank you everyone for watching.